Final exam, Math 60, Form B. So we're going to be solving the final exam. So let's start with problem number 1 in here. So we're dealing here with solve this equation for x. So we got to isolate x, right? We have to leave for x, and we can see that x is here and also x is here. However, we must isolate it, right? Our goal is to get x equals to a number, or we're trying to look for a number equals to x. In this case, we're looking for the expression being to x, either on the left side or on the right side, doesn't matter where x ends up being. So because we're having x's in like two of the sides, what we're trying to look for is move the ones that have an x to one side and move the one to not have an x to another side. Let's proceed with this problem. First of all, let's clear the parentheses. So after clearing the parentheses here, let's see what we're going to get. We're going to have a 3a, right, plus 8x minus a equal to cx. Now, we're trying to leave x by itself, but this guy here, this 8x is, is here, and as we say, we have to look for the x's being just in a single side and the one that do not have an x being on the same side. So what I'm going to do here, but first before moving out, we're going to see if we can combine some like terms. If you look here, we have a 3a minus a. So those must be combined at first. So I'm going to have a 2a plus 8x equal to cx. Now, this 8x that is here, I'm going to move it to the other side. So I'm going to have a negative 8x and negative 8x here. Then that would just leave me with 2a equal to cx minus 8x. Now, I have to isolate for x. I have to leave the x by itself. So the reason why we move all the x's to one side to have them is because just by having them, I could factor the x, taking the greatest common factor, because they do have an x in common. So I'm going to factor the x here, and I'll put parentheses, because that's what they have in common, and I'm left with c minus a. In this part here, I'm left with 2a. Now we're almost there. See, now we have a single x. The x is by itself here. Now I gotta get rid of this whole thing that is multiplying the x. So I'm just gonna, because I'm running out of space, I'm gonna write here 2a equal to x parentheses ca. That's what we had there, right? So we say that we have to leave the x by itself. So I'm gonna divide by the whole amount here. So c minus a, and also I'm gonna do here c minus a. Now by doing that, well, definitely these are gonna be gone, right? So you're gonna be left with x equal to 2a all over c minus a. That should be your final answer. Now let's do the next following problem. And yes, here I have a typo. This says solve for h. Actually should say for solve for w. Okay, so now let's solve for w here. So 2w squared plus 11w plus 15. So this seems to be a quadratic equation. So in a quadratic equation, I'm going to factor here. I'm going to look for the greatest common factor, but they do not have anything in common. Look, 2, 11, and 15 do not have anything in common. So now there are two techniques that we're going to use, that we might use, either the trial and error or AC method, or any method of your choice. Now usually during the classroom you use AC method for trial and error. Along the video, we're just gonna be covering trial and error. This is the only time that I'm gonna be doing an AC method. AC method is really good. It's practical, but sometimes it takes us a little bit longer. So we're trying to shorten some time. But if you have been using the AC method all the time, just stick to that method. So I'm gonna show you how the AC method works first. So we're looking for the AC method. Now, if I'm doing the AC method, then this is my A, alright, A equals to 2, B equals to 11, and C equals to 15. The AC method says that you need to look for a number that give you a product AC, that give you the product of AC, and the product of AC is 2 times 15 is 30, and it has to give you for the sum of B, which is 11. So let's look for two numbers that multiply 30 and add up to 11. Now, let's start with the 1. 1 times 30. Well, 1 times 30 is actually, 1 times 30 is 30, but if you add them up, that's going to be 31. So let's try the next one. 2 times 15. That's add up to 17. So now look about 3 times 10. 13 doesn't work. So how about 4? Well, 4 doesn't go into 30. So 5, I think 5. 5 times 6 is 30. Oh, at the same time, 5 times 6 is 30, right? 5 times, but 5 plus 6 should be 11. So those are your two numbers there, 5 and 6. So what we're going to do, the AC method tells you, okay, you have those two numbers, right? So let me copy the problem again. So you have those two numbers, and what you're going to do is you're going to split this 11. You can split it into those two numbers that you found. So 2W11 plus 5W plus 6W plus 15. Now I'm going to factor this. It's still equal to 0. But let's factor this by grouping now. We're going to group this, and you're going to group this. So what do they have in common in the first group? They do have a W in common. So W out, and you're left with 2W plus 5. Now, here in this second group, what do they have in common? Well, this is a 6 and this is a 15. It appears that they have a 3 in common. So, if they do have a 3 in common, I'm going to pull that 3 out, plus 3, and then I'm going to have to be left with a 2W plus 5. Why? Because 2 times 3 is 6, and 3 times 5 is 15. Now, I'm going to keep factoring this. Now, they do have this thing in common, like the factor here, this that it is between the parentheses, they have in common. So I'm going to pull that out. So I'm going to be 2W plus 5, and I'm left with W plus 3. So that actually equals to 0. Now let's use the zero principle. The zero principle says that if two numbers multiply to 0, then that implies that one of these, like this number here, this factor here, or this factor here should be equal to 0. That's what the zero principle tells you. So we will conclude 2W plus 5 is equals to 0, or we can also say that W plus 3 is equals to 0. So now let's solve each of them individually. Minus 5 minus 5. So then you're going to get 2W equals to negative 5. Divided by 2 each side. Then you have W equals to negative 5 half. That's one of your answers. Or the other one, you have to isolate for W. So you're going to do minus 3, and then you have W equals to negative 3. That's your other answer. So this is how you would have done the problem if and only if you use AC method. AC method, we are using it to factor. Now, what I'm going to be doing along the video is I'm just going to be using trial and error. So let's use trial and error for this problem. So 2W, I'm going to redo the problem again. 2W plus 11W plus 15 equals to 0. Now, let's look for let's do our structure here. Right? This is going to be by trial and error. So I'm going to write probably here trial and error. Because you're just trying, and there are many ways of factoring a trinomial. Trial and error, AC method, crisscross, rhombus, rectangle. There's so many methods about how to factor a trinomial. Use the one that you always been using in class, or the one you feel the most comfortable with. So let's factor in this. Two numbers that multiply 2W could be 2W times 2W. Two numbers that multiply 15 could be 3 and 5. Now let's check this. Probably plus and plus. Let's see. These two numbers multiply to 3W. These two numbers multiply to 10W. That doesn't work. So, see, this number wouldn't work. So let me try to factor again. So this, because 3 plus 10 is 13W. So they need to match the one in the middle. So this doesn't work. So you either erase it or just keep your word there to tell you, okay, you already used those numbers, so then erase them. So let me redo it again. So I know 2W squared is 2W times W, but the 1 and 15, I could have used other numbers. I could use the 1 and 15 as well. But how about if I switch the places? Let's see what happens if I switch the places. 5W times W is 5W. 2W times 3 is 6W over. So 5 plus 6 is going to be 11W. Oh, this one matches. Therefore, what you're going to do is that this trinomial is actually 2W plus 5 times W plus 3 equals to 0. So we end up having the same thing as we had before whenever we were working in this trinomial. So what we're going to get here, so you can say 2w plus 5 equals to 0, or w plus 3 equals to 0. After you have solved these problems, you will end up having w equals to negative 5 half, right? Or w equals to negative 3. So you will get actually the same answers. So be careful whenever you're doing this problem. You can use any method for your choice to factor any trinomial. Let's keep moving for problem number 3. In problem number 3, they're telling you to find the real solutions. So we have this trinomial again. There are 3 terms. Some professors, some students actually like to work this problem out by using substitution. So what they actually do is this thing here. So because you always been working with quadratic equations, and you're so used to see these things here like x squared minus x plus, let's say here you put or a minus 6, okay, minus 6. So you're used to see these things like 3x squared plus 5x minus 2, things like that, right? So we're so used to see this square and this x. That's what we're looking for ideally. So what every other student will do is kind of use substitution here. They will try to say let y squared equals to 2a, and you're gonna replace this y squared for a. So in a way that you will have y squared, I mean, you will have a to the square minus 8a minus 9 equals to 0, and then you can allow to yourself to factor this one here. You could use this. I mean, this is useful. If you've been using that in class, then you're so welcome to do it, because then you will just have to factor this guy here, and remember that then you will have an a here and you will have an a. However, you are not looking for a. You have to finally look for y. So you're going to have to use a back substitution. So whenever you're doing a back substitution, it implies a few other things there, right? So, but to be honest, like this problem doesn't imply, I mean, this is really good to do it, or you can just directly try to simplify this because this is not too complex. Look what I'm going to do here. So what I'm trying to do is, well, I'm looking for 2 numbers. I'm using my trial and error. I told you before, I'm going to be just using the trial and error to factor. So y to the square, 2 numbers or 2 terms that multiply y squared, that actually is y squared times y squared. Now, 2 numbers that multiply the 9. Let's just try 3 and 3. Let's see how that works with the 3 and 3. So if I multiply this times this, well, also you need a negative 9, right? So 1 positive and 1 negative. So it'll be 3y squared. And this times this will be negative 3y squared. And they add up to 0. So using the 3 is not really a good option. So how about if I do y squared and another y squared? And let's look for all the 2 numbers that multiply to 9. So this was a bad option, right? So let's go here. Number 9, probably 9 and 1. So let's see 9 and 1. I need to use a negative and a positive here. Let's look at these 2 numbers multiply to 9y squared, and these 2 numbers here multiply to y squared. So adding them up is negative ay squared, right? Negative ay squared, that's actually the one in the middle. So therefore this works. So what it implies is that the y squared minus 9 times y squared plus 1 is equals to 0. Now, what I'm going to do with this equation, what I have to do is, I mean, they need to be factored completely. But this part here, this y squared minus 9, that doesn't appear to be factored completely. That actually looks like a difference squared. That looks like an a squared minus b squared, which is just a product of the conjugates. Now, because this y squared is like y squared minus 3 squared, see that's a difference of squares. So I'm going to factor this guy here, so it should be y minus 3 and y plus 3. And the other one cannot be factored, that's just y squared plus 1 equals to 0. Now that I have this product equal to 0, I can use my 0 principle that tells you every factor that is being multiplied here, right? One of them should be 0. So either y minus 3 is equals to 0, or y plus 3 equals to 0, or y squared plus 1 is equals to 0. Let's solve each of them individually. Plus 3, then you have y equals to 3. That's my first answer. Or let's do the next one here. Minus 3, and then I can have y equals to negative 3. Let's look for the next one here. Well, I need to isolate for the y squared. So how about if I do minus 1, and then I get y squared equals to 1, negative 1. But wait a minute. Y squared equals to negative 1. And we're looking for real solution. There is no real number. Careful here. There's no real number that is being a square, right? Let's say if you have any real number being a square, that's always positive. So there's no real number that will make this negative 1. So therefore, in this part here, there's no solution, right? Just for this particular case, it's no solution. Like for this one here, you will not have a solution. So your only candidates, the only one that could be a solution is y equals to 3 and y equals to negative 3. Problem number 4. Find the domain of this given function. So if you're looking at this function here, this is actually called a rational function. Why is we call a rational function? Because we have the x in the denominator. It's a rational function. Now, whenever you're looking at rational function, all you need to care about is the denominator part. You gotta care about this bottom part here. And why do we care about this bottom part here? Because in a rational expression or any rational function, the denominator cannot be 0. Cannot be 0. So what we need to do here is, well, let's eliminate this thing. Like, let's try to look for a number that actually makes it 0. So let's look for that number. So x squared, I'm going to set up an equation and find out what number gives me 0. So because this is a quadratic equation actually, you need to factor. So let's take an x out here, and then you're left with x minus 2 equal to 0. Now, if this multiplies to 0, then that implies that x equals to 0 or x minus 2 is equals to 0. Let's solve the first one. Well, the first one is already solved. Then this part here, I gotta do plus 2 and plus 2, and then I have x equals to 2. So now, if this is equals to 2, so it means that once I plug the 2, this is going to be 0. And also once I plug the 0, this is going to be 0 in the denominator. So it means that our domain of f of x should be all the real numbers except, so minus, the set of value of 0, 2. So all the real numbers except 0 and 2. Or you can actually give this in an interval notation. So if you give it in an interval notation, you might want to graph your number line to make this easier. So the value of 0 is here, the value of 2 is around here. So we're taking everything except those values there. So I gotta put parentheses in between there. So you're taking all of these, and all of these. Everything except the 0. So in an interval notation, my domain would have been from negative infinity to 0, union to 0 to 2, and union from 2 to infinity. That's how it would have been in an interval notation. Now, if your professor requires you to do set interval notation, set Builder notation, if you want to do a set Builder notation, then we have to say this. It's going to be the set of all x's such that x belongs to a real number except 0 or 2, right? Except 0 and 2. That would be one case. Or you could also say is the set of all x such that x belongs to this given interval. Then you write the interval here. So using the set builder notation, pretty much you have to say is the set of all x's. This guy here means such that and then you give the expression of x, like x belongs to the interval, or you can say x belongs to all real numbers except the value of 0 and 2. So be careful, whenever you're finding the domain of a rational expression, the denominator cannot be 0. So you take everything, all values of x, except the ones that make it 0. From number 5, they told you to simplify the expression and write the answers using positive exponents. So there are many ways of doing a law of exponents. As long as you're using the law exponents correctly, then you can do this any approach. A lot of students like to distribute the two first for each of them, while some of them prefer to work on the inside. Some of them prefer to change the negative signs for positive. They can use it in many ways. So I'm just going to be consistent using a single way here. So what I'm going to do here is, because I see like I want to focus on the inside first, and I also want to recall this property of law exponent. Say if you have x to the a over x to the b, that implies that it's x of a minus b. So what I'm going to do here is I'm going to do that, and I'm just going to focus on this part here, the top and the bottom, and the top and the bottom. So I'm going to have the 2 by itself there, times, now I'm going to use the operation of this. Got to do x negative 3 minus 4. That's the first one, right? And also it's going to be now on top as well, y 2 minus negative 1. So that's what happens after you reduce the first one. Then all of these being a square. Now you get 2, and I'm going to kind of work these ones out. So x negative 3 minus 4 is actually negative 7 times y. Now, but I have to clear the parentheses, right? If you do negative and negative, it actually becomes plus 1. So you're actually doing a 2 plus 1, and a 2 plus 1 is 3. Then I still have this 2 outside. What I'm going to do now with these 2, I'm going to distribute for each of them. And I want you to remember that the property says, there is one property says, you have x times y to a power of a, tells you that this a could be distributed for each of them, like x to the a times y to the a. Now, one of the properties that we're using is that one. So this power of 2 is going to be distributed for each of them. So you're going to have 2 to the square, and then you have x to the negative 7 to the square, and you also have y to the cube to the square. After doing that, well, what is 2 to the square? 2 to the square is actually 4. Now, how about this one? X to the 7 and then to the power of 2. Also recall that x to the a, then to the power of b. A power to a power, you have to multiply them. So a times b will be your answer. A power to a power will be x, and then to the product of a times b. Now, doing that, so negative 7 times 2 is actually negative 14. So I'm going to have negative 14 here. And then I have y. 3 times 2 is actually 6. But this could be my answer. But the instruction says write the answers using positive exponents. So anything that is on top should go to the bottom, and anything that's in the bottom should go on top. Now I'm going to give you an example here, just a quick example where I'm explaining that thing. So if I have a to the 5th, and then I have b to the negative 4 probably here in the bottom, and then I have a c to the 8. Actually, I'll put here negative 8. So what it means is, like, for example, this a to the 5th is on top, right? It's positive, so it remains in there. But this c to the negative 8 is negative, so it's going to go to the bottom as positive. And b to the negative 4 will go to the top. One of the ways that once I hear about one of the ways that you can actually go through this problem, and I really like it, is, for example, whenever you're changing these negative numbers positive, they say that this is here. Like c to the negative 8 is negative, so it's not happy. So you gotta go to the bottom to make it happy. So c to the 8 now is happy. So, and also if you have here b to the negative 4 is negative, it's not happy, right? So you want to make it happy, then it should go to the top to be happy, b to the 4. So that's one of the ways that I thought it was really nice of putting it that way. So that will help you memorize it or help you understand this a little bit more. So you're pretty much just switching the side. If it's in the negative on top, then it goes to the bottom as positive, and vice versa. So to make this happy, go to the bottom, and to make this happy, go to the top. So that's what we're doing here. So like 4 is happy, y to the 6 is happy, but this one is not happy, so let's bring it to the bottom. So actually that will be 4 y to the 6, and now to make this one happy is x to the 14. So there we go. That should be your answer with positive exponents. Number 6. So you have 2.5 times 10 to the negative 5 and 4.0 10 to the third power. So the instruction says simplify and write the answer in scientific notation. So what you need to do here is we're kind of gonna use our log exponents for the powers of tens here. We're gonna use our log exponents, and for the other part we're gonna be using our calculator, or you can do it by hand. Now let's apply the calculator in here whenever I'm doing this 2.5 divided by 4.0. Now plugging that in the calculator, you will get a result of 0.625. Now times, now we gotta do this power here. We're gonna use the previous law exponent that we did. It was 10 of negative 5 minus 3. Then what I need to do was negative 5 minus 3. Well, I'm gonna have 0.625 times 10 to the negative 8. And remember that they said write the answer in scientific notation. And for something to be in scientific notation, they at least must have one whole number. So this is 0.6. This is not in scientific notation. So ideally, we want the point to be here, right after the 6, not in the 62, because then you will have like 62. You actually need only one digit in the ones place. So 6, yes, right? 6.25. So ideally, you want to have 6.25. Now, but this 6.25 is not, you can just not write 6.25. So on the side, this is what we're going to do. 6.25, how can I write this in scientific notation? So I want this to be 6.25. So we gotta multiply it times something. So it was pretty much one step, one space, right? And you try to say, okay, let's say this was just 10 to the first power. Now, if you just say that it was 10 to the first power, I always recommend this one by checking, like restore. You have to restore your previous problem. You gotta check it to see if this actually matches to the first one. So 6.25 times 10 is actually moving this to the space to the right. It's gonna be a 62.5. And that's not what we wanted. So this should not be your answer. So it should have been 6.25 times 10 to the negative 1. But let's check. Let's restore it. Does it work? Multiplying times negative 1 means that you move your decimal here, and you should have 0.625. And yes, it actually works. So this is the correct one. Okay? So it should be 6.25 times 10 to the negative 1. And do not forget about this guy here. It's times 10 to the negative 8. Now let's combine like terms here. Well, there's no like terms. I mean, let's combine these coefficients here, 10 to the negative 1 and 10 to the negative 8. By using my low exponents, it actually gives you 10 to the negative 9. So this should be your answer in scientific notation. So in problem number 7, we have to find the slope of a line. So whenever the equation is given, we pretty much need to get the form y equals mx plus b, which is the slope-intercept form. So let's isolate for y. So I'm going to have to do minus 8x in each side. And I will get negative 12y equal to negative 8x plus 5. Now I need to divide by negative 12 each side. So that's what I'm going to do. Divided by negative 12, divided by negative 12, and divided by negative 12. Now after doing that, I'm just getting y equal to, and I'm going to reduce this part, this 8, 12, I'm going to reduce it, and probably 4 goes into each of them. So 4 goes into 8 twice, and 4 goes into 12 3 times. And you have the x there. Negative and negative becomes positive, so you have a positive there. And positive and negative becomes negative. They do not have anything common, so you just leave it like that. But what we're mostly caring about is this part here, where this guy here is the slope. So therefore, the slope m is equals to 2/3. This problem number 8. In problem number 8, they're telling you to graph the given function. So we're given the function 3 over 2x minus 4. One of the things that we're trying to avoid whenever we're graphing, we're trying to avoid to construct a table of values. So, I mean, you're so welcome to do that, but actually do not do it because it's time consuming. We're going to be using a slope and a point in order to graph the equation of the line. But always, if you feel comfortable using the table of value, then just apply the table of value. So in this case, I'm going to try to use the slope and the point just to graph this. And remember that we wanted to have in this form, mx plus b. And actually, this happens to be in this form, where this is my slope m, and this is my y-intercept. So my slope m is 3/2, and the y-intercept is 0, negative 4. Now I'm going to rewrite it here. So m equals to 3/2. What implies is that this is going to be rise over run, and also that because this is positive, my line should look like this. And my y-intercept, the point that I have there, is going to be 0, negative 4. So now let me plug this point in here. 0, negative 4 on my grid line here will be 0, negative 4, 1, 2, 3, 4 here. This is my point 0, negative 4. And because my slope is 3 over 2, so in positive, so I'm going to rise 3, 1, 2, 3, and I'm going to run 2, 1, 2. There we go, another point. And I'm going to keep using the pattern. Run 3, rise 2. Run 3, 1, 2, 3, and run 2. Keep using the pattern, 1, 2, 3, run 2. There we go, you have that. Now I'm going to look for the other side. So rise 3, run 2, 3, and run 2, 1, 2. There we go. And that's enough. So I'm going to, now once I join this point, that should be my line. So I'm going to join those points there. Here we go. Try to be, this line be straight. So there we go. That's my equation of the line, and this is actually the function f of x equals to 3/2 x minus 4. And remember, you could always use the table of value. I do not recommend using the table of value because it's a little of time consuming. So just use the slope and a point. And remember the point that you always have here, you want that point to be actually in a specific whole number. You're trying to avoid doing fractions on your grid line, on your grid paper. Problem number 9. Find the equation of the line that passes through these two given points. And write the equation in the slope-intercept form, which means y equals mx plus b. Now, whenever you're looking to find the equation of the line, similarly that whenever you need to graph it, you need two things. You need the slope and the point. You actually need any point there. Okay, so do we have the slope? Well, we don't have the slope. Do we have a point? Yes, we do. We actually have two of them, so you get to pick. I'm just going to use the first one. So do I have the point x1, y1? x1, y1. Yeah, I do have it. Let's call this x1, y1, and let's call this x2, y2. So we do have the point, but we don't have the slope here. So how are we going to find the slope? Remember that slope, you can find it in different cases. Actually, you are given 2 points. So when 2 points are given, you can find the slope by using the slope form, which tells you that m is equals to y2 minus y1 over x2 minus x1. Using that property, so I'm going to have m equals to y2 is actually negative 9 minus 5 over 9 minus negative 5. Let's see what we're going to get there. So I'll have negative 14 over 9 plus 5. I'll have negative 14 over 14. That actually give you that m is equals to negative 1. So now you have the slope. Once I have the slope and a point, if this happens to be any point, then at any point, you use the slope point form, which is y minus y1 equals to m times x minus x1. So let's replace those values that we have. y minus y1 happens to be 5 equals to -1, right? Because this m is -1, x minus -5. I'm going to clear the parentheses if possible. So y minus 5 equals to -1. Negative times negative here becomes plus, so this should be plus 5. Then I'm going to distribute the -1 because I need to clear my parentheses. I got to distribute this guy here. So that will give you -x minus 5. Then I'm going to do plus 5 each side. Plus 5 plus 5. I will get y equals to -x. So that should be your answer. We wanted it to be in the slope-intercept form. It is actually in that form. So that should be your answer. 10. There's a determine whether the graph of each pair of equations are parallel. So parallel, perpendicular, or neither. So let's find the slope for each of them for us to be able to make any conclusion. So you have 2x plus 3y equals to 9. That's what we have in the first one. 2x plus 3y equals to 9. And then we have the other equation that is 3x minus 2y equals to 5. So what we're going to do here is we're trying to find the slope. To find the slope, we actually need to get this thing here. So let's get those two things in each of them. So I isolate for y, minus 2x minus 2x. You will get 3y equals to -2x plus 9. Then let's divide by 3 each of them. And you will get that y is equals to -2/3 x plus 3 because 9 over 3 is 3. And now the slope here, m, is equals to -2/3. That's the slope of the first equation. Let's do the same thing and find the slope of the next one. So I'm going to have -3x each side. And then I will get 2y equal to -3x plus 5. Then I'm going to divide by -2 each side, divided by -2 each side. So I'm actually each term. Then you get y equals to +3/2 x plus 5. Then the slope, this guy here is my slope. M equals to 3/2. Now that we have the slope for each line, like this is the slope here and the slope here, so I need to compare them. I need to analyze, are they perpendicular, are they parallel, or are they neither? The easiest one to check is always parallel. Are they parallel? Two equations or two lines are parallel. So I'm just going to write here a small note. They're parallel if they have same slope. So do they have identical slope? They do not have any, so they are not parallel. Now, are they perpendicular? How do I know if a line is perpendicular? If they are perpendicular, the slope should be the negative reciprocal of the other. So let's see if are they negative reciprocal, which means if one is negative, the other should be positive. Well, this is negative and this is positive. So far, so good. Now it needs to be the reciprocal. Well, 2/3, if I flip it, that actually gives me 3/2. Oh yes, that works. Therefore, the lines or the equations, right? The graph of the equations are perpendicular. The equations are perpendicular. So we're looking for an equation of the line that passes through the point 1, -5 and is also parallel to this graph of the line. So, and remember, the requirements to find the slope of a line are two. We need the point and the slope, right? Or the slope and the point. We need both of them. Do I have a point? Yes, we do. It's here, x1, y1. So that's given. So far, the first one is done. Second one, do we have the slope? They don't give you what the slope is, but they're giving you some information. They're saying that the line that we're looking for is parallel to this line here. So the word parallel means that they're going to have the same slope. So if you find the slope here, then means that the slope that we're looking for is actually identical to that one. So let's find the slope here. So to find the slope, you always gonna have different cases, right? You're gonna be either given 2 points, you're gonna give them a graph, you're gonna be given an equation. In this case, we're given the equation. So to get the equation here, and to find the slope, I need to put it into this form. Let's see if we can do that. So I'm gonna copy the problem again. I'm gonna say that this guy here is x equals to negative 34 y plus 5. Let's isolate for y. So what I'm going to do first, because I don't like working with fractions, I'm going to multiply each of them by 4. By multiplying each of them by 4, I actually going to get 4x equals to negative 3y plus 20. Now I'm going to subtract 20 each side. So we got 4x minus 20 equals to negative 3y. Now after I'm done that, I have to divide by negative 3, each of them. And then if I divide that by negative 3, then I get negative 4 thirds x plus 20 over 3 equals to y. So you know this equals to y, this equation actually could have write this equals to y, actually could have write it here, and it's the same thing. Now this one here is my slope. So the slope, because they are parallel, the slope are identical. So now I also have the slope. So if I have the slope and I also have the point, then I can use this. So at any point, okay, I'm gonna write it here. At any point, I get to use y minus y1 equals to mx minus x1. So let's find the slope of that line. So y minus negative 5 equals to m, which is negative 4 thirds x minus 1. Let's clear the parentheses. Y plus 5 is equals to negative 4 thirds x plus 4 thirds. Then I need to subtract 5 in each side. I'm going to subtract 5, and then I will get y equals to negative 4 thirds x. But now I need to work this guy out here. I'm going to make a space here to do the work. I need to do 4 thirds minus 5 over 1 times 3 top and bottom, because I need them to have the same denominator. 4 thirds minus 15 over 3. And that actually give you negative 11. So negative 11 over 3. That should be your equation of the line in a slope-intercept form. This is in the y equals mx plus b form. This is your answer for that problem. Number 12. Solve the system of equation by any method, if possible. If the system is inconsistent, or if the equations are dependent, state this. So, gladly they tell you to solve it by any method of your choice. One of the methods that we want to avoid is by graphing, because also grid paper is not always provided, and we don't have a grid paper actually here, so you can always do graphing, but avoid that. That's a little bit hard sometimes. So substitution or elimination are good choices. So let's look at this system of equations here. Could we use elimination? Well, to use elimination, they need to have a negative and a positive, and they need to be equal in numbers here, like negative 4 and positive 2. Well, they've satisfied the condition of negative and positive, but this is 4 and this is 2. The LCM between 4 and 2 is 4, so this is 4, but this is not 4. So multiplying it by 2 will do the job there. Now, how about substitution? Would it work? Do we have a coefficient 1, 2, 4, 1, and 2? Yeah, it will work too. So you could also use substitution. It's fine to use it here. But I will go by elimination, just due to the fact that if I multiply times 2, I will get the answer there right away. So let's do by elimination. This is my equation 1. I always like to label my equation. So equation 1, and this will be my equation 2. So what I need to do here is, we say that we need to multiply the second equation by 2. So that means that you have 2x minus 4y equals to 14. And that 2 is actually being distributed for each of them. So you have 2x plus 4y equal to 14. then because I'm doing elimination, I want to add them up. Right? We're going to add them up here. So you will get 4x, this one is actually gone, equals to 28 divided by 4 divided by 4, and you're going to get x equals to 7. But this is a system of equation. Then we also need to look for y. Which equation am I going to use? You actually get to use any equation. So let's just use the first one. So I'm going to write here in equation 1. This is what we're going to do in equation 1. To have the 2x minus 4y equals to 14. The value that you just found for x, you're going to substitute it here. So you're going to get 2 times 7 minus 4y equals to 14. Then 2 times 7 is 14, minus 4y equals to 14. Minus 14 minus 14, you're going to get negative 4y equals to 0. Divided by negative 4, divided by negative 4, therefore y equals to 0. Now I have my x value and my y value. If I just leave my answer there, I'm gonna get points off because this is a system of equation. Therefore, we must answer it in a order pair. So I need to put x comma y as my answer. So my answer should be my solution. I'm gonna write here solution should be x comma y, which in this case is 7 comma 0. I also need to declare if my system is consistent or inconsistent. The system is what the system is. The system is actually consistent. Why is it consistent? Because there is at least one solution. Now, is my equations dependent or independent? The equations are independent because they do not depend on each other. They are two different ones, independent. So this should be your answer for that particular problem 12. You could also use substitution. You will end up having the same answer, but try to avoid elimination. Try to avoid graphing. Graphing works. It works, but it's a lot. So just do not do graphing unless they tell you do it by graphing. 13. Solve for x, graph the solution in the number line, write the solution in set builder notation and interval notation. So they say let negative 9 be less or equal to f of x and less or equals to 6. What it means that f of x is between the values of negative 9 and 6, where f of x is negative 3x plus 2. So we have to look for the values of x that satisfies this condition. So what we're going to do here, well, I know that f of x is all of these. So I'm just going to replace this guy in the middle here. Negative 9 less or equal to negative 3x plus 2. Less or less smaller than negative 6. Smaller than 6. Less or equal to 6. Now let's solve for x. So let's leave the middle just with a single x. So I need to get rid of that positive 2. So minus 2 minus 2. And I will have here negative 11 less or equal to negative 3x less or equal to 4. Then what I'm going to do here is I'm going to divide by negative 3 each side. Each of them. But whenever you divide by a negative number, remember that you must switch the signs, like the equality symbol. So let's switch them. And then you will have 11 over 3 times x times negative 4/3. So that should be your answer. It's telling you that x is between those values. So let's now answer our number line. Our number line should be x between those values. Well, the negative 4/3 is actually somewhere here. And the positive 11/3 is probably around here. So my answer will be everything that is in between them. Like the answer should be the guys between here. And because we're taking each of them, so I'm going to put a bracket in between them. So, so it's up to here. The bracket is up to here. So this should be your answer for this problem number 13. Right? They give you in a number line, right? They also want you to give it in the set builder notation, and then interval notation. So the interval notation, it will be -4/3 to 11/3. So that will be your interval, okay? So you have the number line, you have the interval. How are we going to do the set builder notation? So let's write. The answer should be all values of x such that either 11/3 is greater than x, and right, and that x is greater or equal to -4/3. That will be one way of getting the answer. Or sometimes they actually do this one, say x such that, and then they will start with the other way around. They would be like, oh, x is greater or equal to -4/3, and at the same time, 11/3 is greater or equal to x. They could have given you like that. Or another way that they could have give you is would be x such that x belongs to the interval of 4/3, comma 11/3. I always recommend students kind of doing the integral because it's much simpler. You just put x such that x belongs, and then you put a given interval that you solve for, that you just found. So that's for problem number 13. You have to use this double inequality, and you have to solve for them. Be careful whenever you divide by, you need to switch the sign. The sign of, or you need to switch the direction of the inequality symbol. So you need to switch this direction. 14, they're asking you to find the domain again. Find the domain of each function. So remember this rational expression again. This denominator cannot be 0, right? The rational cannot be 0. Cannot be 0. So what we're looking for is that we're looking for the numbers that make it 0. So I'm going to set this to 0. The -2 -2, and that you get x equals to -2. So it means that you can take anything except the 2. Alright, take everything except the -2. So writing my domain of x, well, you could actually first do your number line, because they might ask you for the interval notation. So it will be negative of infinity to infinity, and the -2 is somewhere here. You got to take everything except the -2. So it means like you're going to put this between parentheses. So your answer should have been from -infinity to 2 union to -2 to infinity. From -infinity to -2 union -2 to infinity. Those two things there. Now, so I'm gonna, okay, let's summarize this. The domain of f of x is actually all real numbers except the -2. Or you can say that your domain is actually from -infinity to -2 union to -2 to infinity. Now, that could have been there, or you could have write this in your set builder notation, such as the domain of f of x is all the values of x such that x belongs to the real numbers except -2. Or you could have just put x such that belongs, and you put the interval there. So that's your domain for the first part. Now in part B, they're giving you that f of x is, well, what is f of x is equal to a square root of 30 minus 5x. Now, this is a radical function. So whenever you're working with a radical function, pretty much gotta understand that the inside here, this radicand, the inside here, this cannot be negative. So what it means that this must be greater or equal to 0. So that's your setup there. Let's find all the values that make this be greater or equal to 0. And those will be the values that you can take. That will be part of your domain. So let's solve for x. -30 in each side. And then you get -5x greater or equal to -30. Dividing this by -5, you'll get x. Now be careful, because you are dividing by -5. What it means is that you must switch the symbol here. Let's switch the direction. And then you will have negative 30 divided by negative 5 is actually positive 6. There we go. So you have your inequality there. But let's graph this. Let's have the geometric representation, which means let's have the number line. The geometric representation is just a fancy way of saying that number line. So 6 is over here, and you're taking all the values that are less than 6, and you're also including the 6. So you're going to put a bracket, and all the values that are less than 6 are actually here, like 0, negative 100, negative infinity. So all of these numbers here are part of your solution. Now let's do domain of f of x again, right? For this problem, it will be, you can actually just give your interval notation, negative infinity to 6. Now, if you decided to give this one as 2 put to 6, and you're including there, so you need a bracket there, okay? So you're gonna have to need a bracket. So now, if we want to give this in a set builder notation, you could have say this is x is all the values of x such that x is less or equal to 6. You could have give that, or you could have say x, all the values of x, such that x belongs to the interval of negative infinity to 6. You could have also give that as your answer. Remember, if you have in a radical function, the domain, well, you gotta look at the inside thing that is inside the fraction, inside the house, that thing there, that radicand, has to be greater or equal to 0. Now in problem 15, we're given an absolute value equation. So whenever you're looking at an absolute value, remember that the inside here, this part here, should be actually equals identical to whatever is in here, right? So they must be identical for them to be the same, right? Or the inside there, the x plus 3, should be the negative of it, negative 9 minus 2x, right? Once again, okay, if you got lost on that one, for example, if we used to have absolute value of x equals to, let's say, 5, then either x, this guy here, they're identical to x, right? The x is equals to 5, identical to that, or x is actually negative 5, the opposite, because absolute value of negative 5 is equals to 5. So that's what's happening there, just with the only difference that you have an absolute value there. So either 4x plus 3 is identical to this number here, or it's actually the negative of that number, the opposite of that number. Now let's solve each of them individually. So minus 3, and I'll have 4x equals to 9 minus 3 is actually 6. Minus 2x, then plus 2x each side. Then you get 6x equals to 6. Dividing each side by 6, you're going to get x equals to 1. So that's my first answer. Or you could get another answer here. Let's clear the parentheses first. So it's 4x plus 3 equals to negative 9 plus 2x. Now let's isolate for x there. Maybe I will start with a variable now. Minus 2x minus 2x. It doesn't matter as long as you reach your goal of x equals to a number or a number equals to x. So 4x minus 2x is actually 2x plus 3 equals to negative 9. Now I'm going to eliminate these 3. So minus 3, you get that 2x is equal to negative 12. Now to leave the x by itself, this 2 is multiplying, so therefore I must divide it by 2. Divided by 2 each side, then I will get x equals to negative 6. So these are your two answers for this absolute value problem, x equals to 1 or x is equals to negative 6. Most of the time in an absolute value problem, you will have two solutions. Most of the time. So remember, the inside is equal to this one identically, or that one is equal to the opposite of that. 16. Solve the inequality, graph the solution set in a number line, and write the solution set in set builder notation and in interval notation. So we're solving this inequality that actually is dealing with an absolute value. So whenever you're doing any equation or inequality that has an absolute value, you must isolate for that one. So let's isolate the absolute value. So, but wait a minute, I have that -3 there. I mean, actually I do have a typo here. I was supposed to write this is not the problem. The problem was absolute value of 3x there. So if we're actually leaving the absolute value by itself, I need to get rid of this negative there, right? To get rid of that negative, I need to divide by -1 divided by -1. Then I will get absolute value of 3x plus 1 should be, wait a minute, we divided by -1, so that implies that you need to switch the direction of that symbol. So must face the other way. So it should be there. That absolute value should be greater than 8. Now be careful. Now how am I going to break this down? So it means that 3x plus 1 is greater than 8. So 3x plus 1 is 8 units away from the 0. That's one way of looking at it. Or remember that the book breaks it down in this way. It tells you that absolute value of x is greater than p. They're telling you either that x is greater than p or x is less than -p. Why? Because you're actually looking at this part here. That this is 0, right? And the number p is somewhere here. You're looking that x is away from there, like bigger than that. It's a little bit hard to analyze that part here. I always recommend you try to understand what it means that x absolute value of x is greater than p. So it means that x is greater than p or x is less or equal equal to -p. So this is a case, right? So it means that 3x plus 1 should be just greater than 8, or 3x plus 1 should be less than -8. Because if it's less than -8, something that is less than -8 is like -10. With the absolute value, makes it 10. So 10 is greater than 8. So that's the analogy there that you could also use. Okay, so you are always welcome to check your answer. Now let's solve each inequality individually. So I'm going to do -1 in each side, -1. Then I have 3x greater than 7 divided by 3 each side, divided by 3 each side. Let's see what we're going to get. X is greater than 7/3. 7/3, what it is? Isn't that about like 2 1/3? Right, yeah, that's actually 2 1/3. So now I'm going to do -1 to solve the next inequality. I'll get 3x less than -9. Now dividing it by 3 in each side, what I'm going to get? I'm going to get x less than -3. Be careful here. We're not switching it here because we're dividing it by 3. We're not dividing it by -3. So we're fine. We don't need to switch. You switch if and only if you divide by a negative number. Now that I have that, it says or. So or actually means union. Like little o there means like a u, like or. So that's union. So you got to satisfy both inequalities. So if I'm doing my number line here, I'm going to graph them in a single one. From infinity to -infinity. And 7/3 is about a 2 1/3. So if 0 is around here, 2 1/3 is probably around here. So it's 7/3 here. And -3 maybe is around here. So just rough estimation here. And also tells you that x must be greater than 7/3, which means you're taking numbers that are larger than that. So I'm going to shade all of that thing here. And are we including that? No, so it just should be parentheses here. Now for the next one, x less than -3. So you're looking for numbers that are less than -3, such as -11, -100, and so on. So because you're not including -3, you gotta put a parenthesis there. Now that you have your number line, it's easier to get your interval notation. The interval notation should be from infinity to -3 because you're taking everything. union to 7/3 to infinity. That should be your interval notation. Now let's write our set builder notation with all the values of x such that x is greater than 7/3 or x is less than -3. That's how you can give your answer in set builder notation. Or the one that I always recommend is easier to just say is all the set of x such that x belongs to in your interval notation here. -infinity to -3 union from 7/3 to infinity.